Ladies and gentlemen, please welcome to the stage John Kreiser, VP International Marketing, Hortonworks.
All right, good morning. Good morning, everybody. Good to see everybody back. Welcome to day 2 for Hadoop Summit in Melbourne. I see that a few people continued the partying after the exhibitor reception yesterday, so people will continue to straggle in. But hope everybody had a great day. We had really positive feedback on the content and the sessions and saw a lot of interaction. Importantly, we were trending #1. The HS16 Melb was trending #1 on Twitter in Melbourne yesterday. So let's see if we can keep up that sharing, keep that going today. As I said yesterday, I don't have control of my slides. There we go. As I said yesterday, we couldn't put this on without our sponsors, so I want to say one more thank you to all of the sponsors that have supported the event, presented, and helped put on a fantastic conference for us today. So again, thank you to the sponsors. One more last round of applause. We took a couple of photos. I'm really got clicker happy here. There we go. Took a couple of photos, so we saw lots of interaction, lots of things going on. There were sessions that were standing room only, which was great. You couldn't even get into them. So clearly lots of interest in a bunch of different sessions. Lots of interaction during the tracks, during the breaks, and people enjoying and generally getting a lot out of the conference. So very happy with that. Hopefully everybody enjoyed the day. We've got a very big day for you today, day 2. And I'm very excited to bring up this thing, battery maybe needs to be replaced. Sorry. Very excited to bring up one of our Hortonworks founders, as yesterday was more about the business use cases and more about to use my Mull analogy, about the business in the front. Today is much more about the party in the back, the technical content and the technical session. And to kick us off today, I'm super excited to welcome to stage Alan Gates, one of our co-founders from Hortonworks. Alan?
Thank you.
Thanks.
I got a new one. All right, thank you. Good morning. And thank you for welcoming all of us to Melbourne. It's been great to be here. It's been great to see the excitement and the buzz around Hadoop here in Melbourne and in Australia. I wanted to talk today about kind of past, present, and future of Hadoop. So this year, 2016, marks the 10th birthday of Hadoop. And so I want to start with a little bit of history, a little bit of nostalgia here for us. Yep, there we go. So, as you probably know, in 2006, Hadoop started out just as HDFS and MapReduce. It was pretty simple. And it started out as an open source project in Apache, was quickly adopted by Yahoo to work on their web map. And soon after they adopted it for that, there were a number of other projects that they started to apply it to. Very quickly, other projects grew up around it in the ecosystem. You see some of those examples here: Hive, Pig, Scoop, HBase, others. And it's amazing to me how quickly this proved itself and that other people started building around it. Some of those projects there, within a year, a little over a year maybe, of Hadoop getting started, those were already, there were other people working on it. And it wasn't just people that were already on Hadoop. Hive was started by Facebook. HBase was started by PowerSet. Scoop was started by Cloudera. So other companies were coming around this and already building on it. And then in the Hadoop community, we started to notice something, which was people really wanted to do more with Hadoop than it could do. MapReduce is a very powerful paradigm for a certain set of problems, but for many other problems, it's not such a good fit. But people were still trying to figure out a way to do that. Things like iterative processing, which MapReduce, frankly, isn't very good at because you have to hold the data and work on it again and again and again. They were trying to find ways to kind of cram that in and fit it in there. And so the Hadoop community thought about that for a while, and they decided the solution to this is we need to break resource management from execution, because MapReduce really combined those two features together. And that was the beginning of what came to be called Yarn, nicely known as yet another resource negotiator, hence the name. And Yarn did that. It broke out the resource management from the execution. And this enabled people to start to write other kinds of executors on top of Hadoop. Now, instead of MapReduce being the way Hadoop did things, it was just one of the options. You could build other tools. And people quickly started to build those other tools. And you can see here just a smattering of logos of things that now run with or on top of or in conjunction with Hadoop. And I want to stress this is only a sampling. There's no way we could fit all of them on the slide if we tried to put everything up there that now works with it. And as an engineer, as a developer, one of the most gratifying things is when people build something on your system that you had never envisioned. That's actually a way, at least I've found in my career, that's a way I know when I'm doing something well. When people take something I built and extend it beyond what I had ever thought of. And I think that's something that happened here with the Hadoop community. They were thinking about how to enable a few more use cases, and people came along with lots of new ideas that had not yet been envisioned to work on Hadoop. I want to focus in on just a couple of those areas. I can't obviously cover all these, but I want to focus on a couple of those areas and how they've also transformed. So, I spend a lot of my time working on Hive, so in a completely unbiased way, I chose Hive as one of those areas to talk about. What is Hive? Well, today Hive is a data warehousing solution on top of Hadoop. It offers extensive SQL 2011 support. It can scale to 300 plus petabytes of scale. There's at least one instance of that size in the world. It's compatible with many BI tools. And now, with some of the work we're doing in Hive 2, it can respond in interactive time and work with tools like Tableau, with a person sitting there clicking and drawing their graphs and getting their work done very quickly. So, as I said on the earlier slide, Hive was one of the very first projects to join the Hadoop community. It was going by at least the fall of 2007, if not maybe a little bit earlier. So it was very early on. Hive became a top-level Apache project. That means it broke out from under the Hadoop umbrella and kind of had its own project management committee in 2010. And at that time, Hive really was a SQL to MapReduce translator, which was very useful. It helped people who wanted to work on Hadoop but didn't want to program in a MapReduce paradigm or maybe didn't know Java to get their work done. Around the time that Yarn came out in 2012, it also became apparent that, well, two things really became apparent. One, Hive could now be more than just a translator to MapReduce, right? We could write the engine underneath Hive that we really wanted to have under there, because MapReduce isn't a perfect fit for what you want, what a SQL engine wants. And it also became clear that as people were putting more and more of their data in here, they wanted much more than a glorified MapReduce translator. They wanted to do traditional data warehousing type things, and Hive wasn't up to that yet. But the Hive community took on that challenge and started working through adding all those features. So in 2012, we started that journey by adding much more robust ODBC and JDBC connectivity, and starting to expand the SQL out to not full 2011 support, but to all the parts we felt were important for the workloads people were trying to take on. In 2013, the Apache Tez Project came along, which was it took MapReduce and it reworked, it tried to keep the security and the parallelism and reliability and all the important lessons we learned in MapReduce, but build an engine that would work well underneath a SQL engine. And Hive adopted that. We also rewrote a lot of the internals of Hive. The operators inside were rewritten. The file storage format was rewritten. We added real authorization. We integrated it with Apache Ranger, which is an external security tool. And I'll talk a little bit about that in a minute. But really what we're doing here is, or what we were doing, was taking all the recent research, all the last few decades of research into how data warehouses should work and applying them to Hive. We were reading a lot of papers out of various academic institutions and research labs and applying that to Hive, and even in some cases interacting with people in some of those labs. We had great collaboration from Microsoft and some others to come and say, yeah, this is the way to do this, or no, that's not the way to do this, here, do it like that. Continuing in 2015, we added transactions and ACID to Hive so that people could do slow changing dimensions and delete data when they needed to, and correct wrong data when they needed to. We also integrated it with Apache Atlas, which is a governance solution, which again I'll talk about here in just a minute. And now this year, with the release of Hive 2.0, we have added LLAP, which is a set of standing daemons that can cache data and apply operators to the data in that cache. Let me talk about that for just a second, because I think this is a huge transformation for Hive. In the beginning, Hive, of course, was bound to the way MapReduce worked. Every time you launched a SQL query, that meant launching a new job. For a certain set of problems, that's really good. It scales out very well. If you want to answer questions quickly, or queries quickly, if you want to deal with queries that are over hot data sets, that's not always so good, because you're giving up the opportunity to cache data. And because you're spinning up new processes all the time, you're paying startup costs. We didn't want to give up Hive's Hadoop level scalability. That was very important to us. So we didn't want to change it into a traditional MPP system that had those scaling challenges. At the same time, we wanted to be able to do those quick queries. We wanted a human to be able to sit at the terminal and interact with their data that's in Hadoop. So LLAP is the Hive community's answer to that, where Hive can now choose to execute queries over hot data sets, queries that it knows are going to produce fairly small human interactive type data sets in LLAP. But it can still, when the query is very large and it doesn't make sense to do it in LLAP, it can still do it in the old style traditional Hadoop way. So we're trying to hit the best of both worlds. How did we do with that? Some early numbers here on how that's going. The green bars are Hive 1 with Tez. The blue bars are Hive 2 with LLAP. These are a set of queries from TPC-DS, and you get an idea here of the kind of speedups we're seeing, about an average of 26x. Now, as I've said, LLAP isn't going to be perfect for every query. Sometimes it's still going to be right to do it the old way, but now we're trying to land in that best of both worlds place. I want to touch a little bit more on that security and governance that I talked about a minute ago. And I referenced Hive working with Apache Atlas and Apache Ranger. And it's not just Hive. You want all your data in your system to be secure and governed, right? This is important. And it's not a trivial problem. On the left side of this slide here, you have all your data. It's coming in from different streams, pipelines, maybe third-party feeds. You're storing that in HDFS files, Hive tables, HBase tables, maybe other places. On the right side, you have a set of policies that you have to enforce. You may have, first you need to classify your data. What data do I need to secure? How do I need to secure it? What pieces of my data are what we call personally identifiable information, PII, that I have to take special care with? Then there may be prohibitions. People, and of course there's simple ones like, only Alan can see this data, or maybe Alan can't see this data. But that's the most basic level. There's much more interesting prohibitions like that than that. Like maybe I can see data in table A and table B, but I can't join them, because if I could join them, maybe I could figure out some personally identifiable information from that, or figure out some things I shouldn't. So even though I'm allowed to see each table, I shouldn't be allowed to ever join them in a query. Or maybe I shouldn't be able to do a query. Maybe I can do aggregate queries over a table, but I can't do queries that select individual rows, because then I could find information I'm not supposed to, right? You may have time-based policies. In the US, there are laws that apply to some financial companies where data can only be seen during business hours to prevent workers from going home at night and hacking into the system and getting some information that if they were at work when they got it, the system would, or their boss or somebody would step on them. There may also be time-based policies in terms of parts of the data may expire after 90 days. You may keep the entire record, but a particular column you want to just be effectively thrown out or blocked after 90 days. And Finally, there can be location-based prohibitions. I can't see this data if I'm not in the same country where the data was produced, because maybe it's illegal to export the data out of the country. You have all those policies. You need to connect those with the data, right? How do you do that? So this is where we use Apache Atlas and Apache Ranger to solve this. Atlas is a governance solution. It can do tagging of data, so users, your team that's responsible for creating the data can go in and say, okay, I know that this data contains PII in these columns. It also supports lineage so that as that data moves through your system, once it's tagged once, that can follow it along. You don't have to tag it at every point. And finally, it gives you the ability to build data hierarchies and explain how pieces of the data are interrelated so that your users can figure out how this piece over here is related to that piece over there. And Ranger we use to do the actual enforcement. So this understands the tags that Atlas puts on the data, can enforce them. If, for example, data is tagged as PII and I don't have permission to see it, Ranger will deny me permission to see that column. In fact, it may even hide from me the fact that that column exists. When I do a describe table, I may just not be told about that column. And it can enforce these other time-based and location-based prohibitions so that users only see the data they're supposed to see. All right, so to talk a little bit more through that, I would like to invite up Ryan Peterson, who's the Chief Technology Officer at Data Republic. Welcome, Ryan.
Thanks, Alan. Appreciate being here.
Yep.
Good morning. The clapping subdued a little bit, so I think it's the drinking from last night.
Yes, it's an early morning. So Ryan, tell me a little bit about Data Republic, how you guys use Ranger and Atlas and other tools.
So, just on that last slide, you saw there was, in Atlas, things have been tagged as monetary assets, and more we believe, at least at Data Republic, that those assets are becoming more valuable, and especially more valuable to other organizations outside of yourselves. So just getting to the point where you can understand what's within your environment and what those assets are and how to tag them and who should have access to it is kind of step one. And what we've done is really taken that to the next level and believe that Atlas allows you to tag it as an asset. We allow you to figure out how to use that asset with another organization altogether. So to kind of give you an idea of what that looks like is you can imagine grocery data, credit card transaction data, airline data, all sorts of information could be very, very valuable, not only to that organization to monetize, but to the organizations that can consume it and use it for something else. But really, in order to get to that point, we've got to have a governance system that allows for that transaction to happen between the organizations. So what we do is we build on top of these capabilities like Atlas and like Ranger to create an additional scale, additional level that allows you to communicate in between all these different organizations. But the first thing I get asked is, well, what about privacy? We just talked about PII being a big issue. So by designing a trusted platform from the ground up, we realized that personal information needs to be put in its own place. So you see on the screen there is this concept called Data Bank. Data Bank was just announced this week as an available platform. And what it does is it strips out the PII. So you can see Atlas identifies that these columns are PII. We strip those out and we send them to a different place. And so Data Republic only has to deal with anonymized content, but at the same time, it gets tagged with a token, and that token can be used to re-identify the person back to that organization at some point. So it becomes a really good, trusted way to be able to communicate between platforms. And we're an Aussie-based company that has stood up from an Australian startup, and we're looking forward to really creating some new things around governance for you guys.
All right, so I heard a rumor that you had a very exciting announcement yesterday. Can you share that with us?
Absolutely. We're really excited because we just talked about with governance and getting to the point where people can exchange information between each other. It doesn't support the liquidity of data, though. What we needed to do was make it so that people could easily find insights and information out of the information that belongs in our platform. So, for example, grocery data might connect with credit card data to create a new insight. So what we've built is this concept of the open data marketplace. And the open data marketplace really has three different major aspects. It could be raw data, just information that you can go find and search for. And the second thing might be a list of scenarios that you could take those raw materials and create something unique from it. And then finally, if somebody's already done that, so a lot of you guys are partners and have data scientists, for example, you can go create these insights and make those insights available on the marketplace as well. So in the end, what we've given you is really both a secured, trusted, governed platform, along with a way to go find different assets and enhance and enrich the data that you have within your environment. We believe this is really going to change the world for good. The last thing I'll kind of leave you with on this is we've done a lot of looking into social good programs. And the information that you have within your environment, the information we already have in the Data Republic environment, it really can lead to social change in a very positive way. So as you leave this discussion thinking about governance, security, trust, also think about your data and what your data could do to change the world for good. And I really appreciate the time that you guys have given me to talk about what we're working on.
Thank you very much. It's very exciting. All right. Thank you. It's always good to hear from people who are making use of this and building new things on top of it. All right, I want to pivot now a bit. We've been talking about the past, I talked a little bit about the past, talked some about the present, where are we at today. Now I want to talk a little bit about where Hadoop may be going. And obviously I can't cover all that. That would take a long, long time. But I want to focus in on one area that I think is really, really driving Hadoop development right now, and it's going to be a big part of it over the next few years. And that is obviously the move into the cloud. I'm sure many of you are already participating in this or know a lot about it. A lot of processing nowadays is moving into the cloud for a number of reasons. So it makes a good sense to ask, why would you do Hadoop in the cloud? Why would you do Hadoop in the cloud? What would be the advantages of it should you make that move? We see people really moving into the cloud for kind of about 4 reasons. One of the biggest ones is just agility, time to market. How long does it take you to get a cluster up and going? And I don't mean up in terms of installed, I mean up in terms of planned out and built. If you do that in your own data center and you have to go buy hardware, get that hardware shipped, get it built out, racked up, wired up, OS is installed, all that, in our experience, that's often a 6 to 9 month process. It can take a long time. If you wanted, you could all have clusters running in the cloud before I finish this talk, right? Well, you probably couldn't all, because you'd probably crash the wireless if you all started, banging away on that. But in general, you get the point. Related to that, obviously, is upfront costs. If you're going to build out a cluster on premise, you're going to pay all that cash up front to buy the hardware, rent the data, rent the colo space, all that kind of stuff. In the cloud, you're going to pay as you go and only as you use it. So you don't have to allocate the hundreds of thousands or millions up front to get yourself up and running. Related to that is the scaling, right? The cloud offers you much more dynamic scale. If you're going to build a cluster on premise, you have to plan up front for your busiest hour. If you're a retailer, that probably means you're planning for the few weeks before Christmas when you do most of your sales. And during school vacation time, though 50% of your computers are probably sitting idle because you only need that capacity when you're right before Christmas. In this cloud, not an issue. You rent what you need right now, and you give the rest back to the cloud. Another interesting dynamic is when you run on premise, you have to keep it up and going all the time. In the cloud, you can stand up small clusters just focused on what you want to do, run your job, and shut it back down. It can be ephemeral instead of long running. Now, whenever you shift the architecture of something, not surprisingly, that changes the requirements on that platform, right? As Hadoop moves to the cloud, there will be some shifts in the way Hadoop needs to run. And just to be clear, Hadoop obviously already runs in the cloud. From day one at Hortonworks, we've done much of our testing in the cloud because we couldn't buy all the hardware up front either. But as Hadoop needs to fit well into that cloud environment, there will be some shifts. One of those is shared data and storage. You're not going to, if HDFS isn't long running in the cloud, you're going to be storing your stuff in the cloud's object store, such as S3. As I already said, a lot of workloads will be on demand or ephemeral instead of long running. It's not just your data that needs to endure a long time in the cloud, your metadata needs to. It doesn't do you any good if you create a bunch of tables and tag the data as PII and create security policies, and then as soon as you turn your cluster off, that all goes away and your data is just still sitting in an S3 bucket. Your metadata, your security, all that stuff has to be long-lived as well. And finally, resource management requirements in the cloud are very different than they are on-premise. And so I want to walk through each of these a little bit. The shared data and storage. As I already said, you're going to store your data in whatever the cloud's object store is, partly because your clusters probably aren't running all the time, partly because you want to share them between clusters, and partly because you probably have completely non-Hadoop-oriented workloads that want to access this data and will want to talk to S3, right? That, or S3 or whatever cloud you're using. There's some obvious advantages to this. The cloud solves DR problems for you. You don't have to worry about loss of a data center causing loss of your data. They often have built-in geo-distribution, so you don't have to worry about copying it to different parts of the world. On the flip side, there's a couple issues. Cloud stores aren't generally highly consistent. They're usually what you call eventually consistent, which means you write data, and someday it'll show up, usually fairly soon, but there's no guarantees. That doesn't work well with a lot of Hadoop tools, or frankly, a lot of other tools. Most applications expect strong consistency, and it's much easier to write applications as a developer when you have a strong consistency guarantee. Also, cloud stores don't tend to be focused on read performance. They tend to be focused on those other things I was talking about. And so we need to work to make sure we don't give up the recent performance gains in Hadoop and Hive and Spark and other tools by moving into a cloud environment where it takes us a long time to read because compute is separated from storage. So how do we address that? This is where caching is really your friend. And there's a couple types of data you have to think about caching. There's table data, tabular data. I already talked a little bit about LLAP. One of the reasons we're so excited about it is in the cloud world, it becomes even more important to have aggressive, appropriate caches. And in fact, we're even looking at how it will make sense to put SSD storage in those machines so that when LLAP does need to spill its cache, it can spill to that SSD and recover the data much more quickly if it needs to, rather than letting it go and having to go clear back to S3 to refetch that data. We also need to work on write-through caches for that so that data that's written into Hive can very quickly be accessed instead of having to wait for the loop to go through S3 and show back up and then come into the cache. You can also apply all your security policies through LLAP, because S3 isn't going to give you the ability to do location-based security or time-based security or any of those things, but we'll be able to apply those there. For non-tabular data, for files, HDFS can act as your caching layer because it will be running on those machines that you are using to run the cluster. And it also needs to work on having a write-through cache so that if you stored HDFS and you want that data to be permanent, it's pushed back to S3 behind that. Because in general, in a cluster on the cloud, once that cluster is shut down, all the data in it's lost, right? So you can't just store it in HDFS and expect it to be there forever. It needs to write it back through underneath. Prescriptive on-demand workloads. This is particularly a powerful shift, right? In the world of on-premise, you spend a lot of time setting up a cluster and tuning it for all the different things that you want to do. You need to be able to support your data scientists who want to run Spark, your analysts who want to run Hive. Maybe you have somebody who wants to run text search, so you have to install Apache Solr. You have all these tools you need, and you have to balance your cluster to support all those users. In the cloud, you can be much more prescriptive about building different clusters for different user types. So you might have a data science cluster that just has Spark on it, and you only spin it up when a user comes along who wants to do some data science. One of your data scientists says, hey, I have this great idea. I think I know how to save us a bunch of money. Let me, give me a cluster of 5 nodes, and I'll play with it for 4 hours, a day, 2 days, and I'll figure out if this idea is great or not. That's easy to do. You spin it up, you run your calculations. As soon as it's done, boom, you turn it off, done. Similar for other types of workloads. You might have data warehousing workloads, ETL workloads, search workloads. All right, as I said, it's not just your data that needs to be long-lived in the cloud, it's your metadata. And what do we mean by metadata? That word is sorely overloaded, and we need, honestly, we need better vocabulary to think through what all this is. But it includes it includes a number of things. It includes data about your tables. What is the contents of a Hive table? What S3 buckets or HDFS files or whatever map to this Hive table? It might also be tabular data for data in a stream. What Kafka queue maps to this table? There's data about lineage and provenance. How did this data get to where it is? Where did I get it from? What changes have I made to it? And then obviously there's all the tags and stuff that we've already talked about in Atlas. There's the security policies in Ranger. All these things together form your metadata that needs to be long-lived and needs to work across clusters, so that if I start up a cluster and do operations on data, maybe I create a table in the warehouse, and then I shut down my cluster, and you come along, and you should be able to go to Atlas and discover, oh, Alan created this table, and it's exactly what I need. How convenient. And I can read that data, and there's the schema, because he stored it there. Even though my cluster may have been shut down long ago, you can still make use of that work. We need to be able to share all that. Finally, resource management is completely different in the cloud than on-prem. So on-premise, Yarn is given a fixed set of machines, and its job is to manage what's the best use of these machines based on things I've been told about priorities and queues and all that. How do I make sure everybody can get their work done? In the cloud, it's less about fixed number of machines and more about fixed budgets and SLAs. So you might have, obviously you want to control your spend on the cloud. You don't want to give your business to Amazon or Microsoft or whoever. But at the same time, you want to get your work done. And if the scheduler can understand that and understand the different costing options, it might look at some work it's trying to get done and say, okay, my SLA says I'm supposed to be done with this in an hour. But I realize I'm just not going to get there with the amount of compute I have. But I have budget to go get more compute. And right now, the spot instances are cheap, so I'll go grab some spot instances. And then I think I'll make my SLA at that point. Conversely, it might go the other way. It might look at the current number of machines it has and say, I'm going to make my SLA easy, and I'm spending too much money. Let me bleed some of these back and give them away so that I don't spend my money unnecessarily. That's obviously a big change in the way Yarn works, and something we need to, some work we need to do there. So enough talk. Let's actually do some show here. We've been doing some work in Hortonworks to put together tech previews of these ephemeral clusters in the cloud, and I'd like to invite up my colleague Rajesh Balmohan to walk us through a demo of those. Welcome, Rajesh.
Good morning, everyone. Alan gave or covered a lot of details about why do we need to move Hadoop onto the cloud. I'll be talking more about the tech preview that we recently had through the lens of a customer scenario. The customer scenario that I have in mind today is an ad management use case. Today, your customers might be coming in from various devices like desktop, laptop, mobile, as well as tablets. It will be really helpful if we can collate the customer experiences across these various devices and be able to figure out what is the right channel that you need to be investing your money in so that you can maximize your revenue. For this, I have different sample data sets in my S3 bucket. So let's have a look at the S3 data that I have. So I have campaigns data set, which contains the marketing details about the various campaigns that I ran over a period of time. I have clickstream data set, sales history data set, as well as user-related information. On top of this data sets, I would like to run different kind of workloads. For instance, I would like to run a ETL workload wherein I can consume this data set, cleanse it a bit, and create a curated output which can be consumed by the downstream applications. Or it could be a BA workload wherein business users might be able to come in, look at this particular data set and create some interactive dashboards. Or it could be a data science workload wherein data scientists might be able to explore this data set and run some algorithms like machine learning algorithms or predictive algorithms and so on. So let's look at the cluster that I have in terms of processing this particular data set. So for this, I'm going to be logging on to the Hortonworks cloud. So it's already logged in. I'm logged in as R. Balamohan at hortonworks.com. I have two pre-created clusters over here. One is for the ETL cluster, and the second one is the BA cluster. So the ETL cluster is the place where I would like to run some Hive scripts in terms of periodically mining the data set and create a curated output out of it. And BA cluster is the place where I would like to log in as a BA user and be able to create some interactive dashboards. So let me log into the Hive view of this particular cluster in terms of showing you the script that I have. So this is the ETL script that I have, which will run on a periodical basis to generate the curated output. There are a couple of things that I would like to point out about this particular script. One is about the data location. So if you look at this particular scripts, all the create tables or the entire script is running on the data set, which is already located onto the S3 bucket, which is external to this cluster. However, we do anticipate that the intermediate jobs can end up generating the data set, which can be located onto the local HDFS cluster itself. Just to give an example of it, the third or the fourth job in this ETL pipeline is a enrich_temp table creation, which ends up generating the data which can be stored onto the local HDFS itself. The second thing that I would like to point out is about the metastore of this Hive server. The metastore of this Hive instance is running on a PostgreSQL, which is located in Amazon RDS. So when you spin up your ephemeral cluster, you can point to the external data set and also point to the externalized metastore, which has some metadata information about the data set that you are planning to use. Third thing that I would like to point out is about the security mechanisms. So if you look at this S3 location or the S3 URL given over here, it doesn't have any information about the username or the password. If that is the case, how do we even ensure that the right set of jobs and the right set of users are able to access this bucket details in a lot more secure fashion? In order to achieve this, we have very tight integration with the underlying object store's security policies. And in this case, we have tight integration with Amazon's bucket policies as well as the IAM roles. Let me show you an example of how a bucket policy would look like. So for that, I'm going to log on to the Amazon's S3 Bucket Explorer, click on the Edit Bucket Policy here. And as you can see, there are two IAM roles that are already defined. One is the DW Reader, and the second one is the DW Writer. The DW Reader as well as the Writer have got access to perform certain operations like get object as well as list bucket operations on this bucket. However, the DW Writer has got some additional permissions like deleting an object or putting an object onto the bucket. So basically, it has got read as well as write permissions. So with this way, you can have fine-grained control on the set of operations that needs to end user needs to have on the specific bucket. Also, it is possible to associate these IAM roles at the time of spinning up your cluster. So that's pretty much what I wanted to show in this ETL cluster. Let me navigate back to the command center in terms of showing you what's possible with the BA cluster. So the BA cluster has got some additional components like Hive on LLAP, where LLAP is a sub-second execution engine on top of Hive. And it also has got Apache Zeppelin, wherein Zeppelin is an open source data analytics tool, wherein it lets the end users mine their data set using different languages like Python, Scala, or it could be via JDBC interface as well. It also lets the end users create some interactive dashboards as well as interactive notebooks. Let me open up the Zeppelin UI over here in terms of figuring out how the curated data set can be consumed. So this is the notebook that I already have for this demo, which has got a bunch of SQL scripts which are given over here, and it fetches the queries or fetches the results based on the execution with Hive via the JDBC interface and pulls out the information which can be plotted on this graph. So let me click on the run button over here. So this query is getting executed against Hive on LLAP. So as you can see, it took almost like 3 seconds in terms of executing this query and fetching the results. So as per this data set, the first graph provides details about the desktop sales versus the mobile sales. And as per this data set, the desktop sales is far more significant than that of the mobile sales. The second graph provides details about the sales lift that has happened due to the mobile conversions. So we observed that whenever there was a marketing campaign run for the mobile users, the overall sales conversion was significantly higher than that of the other scenarios. There are a couple of other interesting graphs, but I would like to touch upon the last one, which provides details about the sales by time of the day, wherein people tend to do a lot more shopping at around 12 in the afternoon as well as 4 o'clock in the evening. That's pretty interesting. I'd like to go back to the command center again and show you how to create a cluster. So you can pretty much spin up your cluster by just filling up a small form given over here, wherein you can fill in the cluster name. You can have your cluster name as ETL cluster or a BA cluster and so on. And you can choose different kind of HTTP versions that you have got, 2.4 or 2.5, and different type of cluster types. Or like based on your workload, you might want to choose the ETL or the analytics or the BA workload. And based on that, different components will be installed in your cluster. It also allows you to choose different hardwares that you'd like to spin up in your cluster. For instance, you could choose a small machine or a large machine or an extra large machine, which are given in the Amazon EC2. You can fill in a couple of other details and click on this Create Cluster button in terms of spinning up a cluster, and within a matter of minutes, your cluster will be up and running. I'd like to also point out that it is possible to dynamically increase or decrease the capacity of the cluster depending on the kind of workload that you have. Just to give an example, let's say that I would like to increase the capacity of the ETL cluster. I can navigate to the ETL cluster and click on the resize button over here in terms of increasing or decreasing the number of nodes at runtime. So that's pretty much what I wanted to show in this particular demo. Back to Alan. Thank you. Thank you.
Thank you. That was very interesting. And I want to point out, if you want to try that, there's the URL right here. You can go play with that. It's available today. And of course, also, we have Hortonworks runs HD Insight for Azure. So it's also, you can also go try out Hadoop in the cloud on Azure as well. All right. So to wrap it up, where is this going? What's our vision for where Hadoop goes in the cloud and on-premise? And you've already seen this slide today, in this conference, it was yesterday. But this is kind of our vision of where things are moving to. You will have data on the edge, maybe in a connected car, maybe in a factory, maybe on an oil well rig. You will have data in motion moving between the edge and your HTTP instances, or maybe moving in between clouds, and then data at rest. And this will happen on the cloud and on-premise. We need to be able to move data back and forth between those. We need to be able to support your applications wherever the data is. In fact, you as a user may not even know where your data is, and that should be the world we want to get to, where it's completely interchangeable between clouds, between cloud and on-premise, between different data centers. So that's a world where you can derive continuous insights from all your data, from origin to rest, where the security and the governance and all the operations, all of that is enterprise ready and enterprise scale, where it can be any delivery model, cloud or on-premise or hybrid. And as always, we want to keep that open and in the open source community, because honestly, nobody but open source can keep up with the speed and the variety and the change that's coming. All right, I'd like to leave you then with a thought of a couple talks that, if you're interested in this, I think you'll find interesting. There's a talk later today by Rajesh where he'll go into deeper detail on Hadoop and cloud storage. And there's also a talk on Apache Kafka security and its future roadmap later today. With that, I say thank you very much, and please enjoy the rest of the conference.
Thank you, Alan. Thanks, Alan. Thanks for taking us through the previous 10 years of Hadoop and giving us a vision for where you see Hadoop going in the future. So, and then as well, thanks Rajesh and for our demo there. So, moving forward, what I want to do is we have a pretty important announcement that we'd like to make here, Hortonworks that is, at the conference, and share with everybody here. And it's really concerning what we're planning on doing next year as you start to think about, after today, coming back and coming back to the conference. So what we're doing is we're announcing an umbrella. We want to expand the community, expand the number of people who can come and share at the conference. And we're announcing something called the DataWorks Summit. So that's an umbrella conference that is going to allow us to bring in even more people, even larger audiences, even more community to share with the information that you have today, sharing the technical details, sharing the business benefits, the transformational use cases that you're hearing about yesterday and you'll hear more about today. So let me just tell you exactly how that's going to work. So we're going to expand the conference so it includes Hadoop Summit. So we'll have a call for papers, all the standard things that we did. There'll be keynotes related to Hadoop, all the track, all the technical detail and transformational information. But we're also going to include some other summits inside of that umbrella. So we'll have a summit on cloud, we'll have a summit on streaming, on DevOps, so development related, and then IoT related components. So there'll be different components or sub-summits, all part of the DataWorks Summit. Now, of course, we'll have all the goodness that we had and that we've built on, the momentum we've built on here for Hadoop Summit, but we'll expand out on that. So there'll be even bigger community as we come back here next year. So what we're going to do is that summit will be in the same location. We'll have it back here in Melbourne, August or September, still working on figuring out exactly what that'll mean. But as you're thinking about next year, I'll encourage you to also think about some of the other components and some of the other mini conferences, if you will, that are going to sit underneath the DataWorks Summit. So, also, as I leave you for the rest of the day, continue with the conversation. There's the Hortonworks Community Connection. It's a place where you can share ideas, get answers to technical questions and deployment-related questions, and not just on Hortonworks components, but really on a broad set of open source projects where you can get answers and really continue to share the information and learn from others who have maybe gone down that path. Do that. We'd like to ask you to continue to tweet and share both on the hashtag HS16Melb as well as on the Hadoop Summit Facebook page. So continue to share that information, continue to leverage the community, be part of the community, and actively participate. So now, for the rest of today, what do we have up? So lots of sessions today. We're going to move from this directly into sessions, just like we did yesterday, from 10:10 to 10:50, and then we'll have a morning break. So the sessions, let me say, are in the same places they were as they were yesterday. So just to your right, my left, and then one floor below us, the meeting rooms that we were using yesterday. So same rooms. Then we'll have morning tea, which will be, again, down in the first floor in the exhibitor reception area. And then we'll go from sessions from 11:20 to 12:50. So a couple of different sessions back to back. Then we'll have lunch, again, back in the exhibitor reception area all the way on the first floor. Then sessions in the afternoon, another break, another chance to get together, share, and exchange ideas. Final set of sessions, and then for those interested, there's the Birds of a Feather sessions, again in the meeting rooms, in the presentation rooms here and on the floor below us. If you want to get together, all the information about the Birds of a Feather sessions are in your conference guides. You can go and look that information up and understand if there's something you want to participate in. So with that, I would like to turn you loose to go to the sessions. Thank you very much for joining us today, and we'll see you again next year. Thank you.